Welcome back. Now we're going to be spending a good chunk of this course building some projects and using some built-in Python modules, as well as using some popular third-party libraries from Python Package Index. However, I wanted to just show you a quick video on some of the useful modules that I personally like in the built-in modules that we have from Python. And some of these really useful modules actually allow us to have more data types in Python. Remember this list at the beginning of the course where I talked about the data types that comes with Python? And then we learned about classes and how we're able to create our own data types, our own objects in Python. But we also have these specialized data types that come as, well, built into the Python standard library, which are really, really nice. And this can make our programs really, really powerful. Now, they're specialized because you're not going to see them everywhere, but it's good to know that they exist, and I'm going to go over some of my favorite. The first one I'm going to show you is the collection module. So the collection module is from collection or collections. And there's three things that I really like here. So I'm going to say import. I'm going to import the counter, the default dictionary, and then the ordered dictionary. Now notice how some of them are classes because they're capital letters, and some of them look to be just a function. And you can read up on the collections module by just, again, scrolling through here and just looking at collections, and you can see all the ones that we have. So in these collections, let's start off with the first one. A counter is extremely useful. Let's say I have a list that contains 1, 2, 3, 4, 5, 6, 7. And I want to count how many items in a list. If I do print counter, you can see over here what it does. But essentially, if I give it a list and click run, all right, what just happened here? It creates a dictionary where 1 has 1, 2 has 1, 3 has 1. What if we add another 7 here? Let's say 7. If I click run, did you see that? 7 now has 2. So what it does is it creates a dictionary that keeps track of how many times an item occurred in an iterable. So that 7 occurred twice, so 7 has a value of 2. Another way we can use this is, let's say we have a sentence, and say in the sentence, I want to check, well, let's just write something. I'll say blah, 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 thinking about Python. If I was to do a counter here, and let's say give it sentence, if I click run, check that out. I see which letter occurred the most. In our case, H occurred 5 times, space occurred 5 times, and then B occurred 4 times. And this is really, really cool because this type of calculation of a counter, of turning an item like a list into what we call a hash map or a dictionary like this to keep count, is actually a very useful function that you see all over programming. It actually helps a lot with optimization problems. Now, we were not going to get into it there, but I just wanted to show you that counter is something that is really, really useful. If you want to count duplicate users or duplicate emails, counter can be really, really useful. What about the next one? Default dict. God, that's a really hard word to say. All right, so let's say we have a dictionary here, and this dictionary will have, well, a very insignificant dictionary. We'll have A1 and B2. What a simple dictionary. Now in here, I can say dictionary dot or bracket A, and I'll be able to grab the value right? If I click run, oh, and I did not spell dictionary right. Let's fix that. That's better. Let's comment this out for now because we don't need this. You'll see that I get a value of 1. But if I try to access something that doesn't exist, like C, I'll get an error. With a default dictionary, I'm actually going to get a default value if something doesn't exist. So let's convert this into a default dictionary, like this. And now if I run this, we get an error. First argument must be callable or none. So what default dict does is it allows us to access a key like this, but give it a default value. In our case, we need to give it something like a callable object in here. And callable means something like a function that can be called. So if I do run, I get 0. Why is that? Well, when I run int like this with nothing inside of it, we get 0. So a shorthand way, because this is going to be run, is to give it a quick function that we're not going to use. So let's just do a lambda and just give it, let's say, 5. So now if I run this, let's do dictionary here. Run. Oh, and let's try and grab something that doesn't exist. If I click run, I get 5. So this is a common pattern you see with default dict. We just give it a value or a callable object. In our case, we're just giving it this function, a lambda function, that simply returns 5. So I can even say in here, does not exist. The second parameter will be whatever we want. And if I hit run, I get does not exist, even though I'm accessing a key that, well, doesn't exist. Now, if I do A here and I click run, everything works. I still get 1. And if I do B, I get run as well. Again, another useful little data type. Next one is ordered dict. And this one is another interesting one. An ordered dictionary retains the order that you insert into a dictionary. Let me show you. So if we have, let's say, dictionary, and this dictionary will be an ordered dictionary. So this is how we create it. Now, in here, if I do D equals to A, and this is going to equal to 1, and then D, B is going to equal to 2, and I now copy this and make a second dictionary. Let's say D2, D2, D2. And I check, hey, print, does D2 equal D? Remember, this is going to check for the values. If I run this, I get true. Yep, they're equal. But if I change the order of insertion here, and I click run, I get false. Sorry, this is not the same thing because it maintains the order. If this was a regular dictionary, so let's say instead of what we have here, I'm going to just simply create a dictionary, and we'll just do a simple C here that has, let's say, 100, and do the same for this one as well. D2 equals to this. If I now run this, I get true because all the keys and values are the same. With a regular dictionary, we don't really care. There's no order. And I mentioned this before too, right? A dictionary in Python has no sense of order. Although when we print out the keys, we might get things in order. As our dictionary gets larger and larger, there's no guarantee that when we print out all the keys that we're going to get them in order. In the case of an ordered dictionary though, we get that guarantee. Now there are some performance implications for those. However, overall, it can be useful in some situations. All right, a few more to go through, but this video is getting long, so let's take a break and I'll see you in the next video. Bye-bye.